Hey everyone, welcome back to another ChemiVid. So today we'll be talking about general balances, or as I like to call it, chemical engineering accounting. So as a chemical engineer, there are certain conservation laws that you should be aware of, and certain things that you'll have to account for in different systems. So those things might be mass, energy, a specific species, dealing with maybe a chemical reaction. You may even have to account for momentum in like a fluid. So as you can see, these three, mass, energy, and momentum, are all conservation laws. You've heard of the conservation of mass, conservation of energy, the conservation of momentum, meaning that it has to come from somewhere. Mass isn't created or destroyed, energy isn't created or destroyed, momentum isn't created or destroyed. And there's a way to account for that. Species are a little different because you can have things react and turn into a different species, but there's a way still to account for them. So to get this discussion going, let's first talk about a control volume. Here I have a box. This could be my control volume. Really what it is, it's an area that you're looking to focus on in a system. So it could be something as large as a distillation column. A distillation column, those are really, really large. And probably one of the biggest pieces of equipment that you'll deal with as a chemical engineer. Or it could be something as small as a box that has dimensions of dy dx, like that. It could be differentially small. That's the beauty of a control volume. So what we're looking to do is to account for mass, energy, momentum, or species that are going in and out of this volume, or that are inside of the volume. So let's think about what could happen, right? I could have mass, energy, species, or momentum enter into this control volume, right? So things could go in. That also means things could go out of this control volume, right? If something can go in, something could also leave, or leave here, or leave here, like that. We could also have stuff being generated inside, right? Or consumed inside. Right? So I could have stuff that's been inside of this control volume that's maybe reacting away. And finally, you can have stuff that's just accumulating over time inside of the control volume itself. So there's a way that we can put all of this together into one equation. We can say that accumulation equals everything coming in minus everything going out, plus everything that's being generated inside of the control volume minus everything that's being consumed inside of the control volume. Now, it's often written this way when people first learn: in minus out plus gen minus consumption equals accumulation. And people oftentimes will just write it in minus out plus generation equals accumulation. And they just say that, okay, generation can be positive or it can be negative depending on whether you're consuming something or producing something in like a chemical reaction. So it's given the nice little acronym of IOGA. In, out, generation, accumulation. And you can just remember that generation could be negative if you're consuming something. So like I said, balances, it's accounting for everything that's in that control volume. And it'll become more apparent what these are as we study the different types of balances that we talked about, like mass, energy, species, and momentum. And as we continue throughout these videos, you'll be able to understand why we pick certain control volumes and why we may not want to pick certain control volumes over time. So that is the end of this video. Hopefully you understand what a balance is and you understand the general form of balances that we will then take into more specific types of balances.